So let's start with the first question here. It asks about calculating 8 times 12. Easy question, but the point here, how to do easy question, it will be applied. So now come to the third question in your test. It's asking to calculate 124 times 7. So the first thing, don't forget, put it into column method. So 1 to 4 times 7. And where we should place the 7? Yes, exactly. It will be under the first digit. So first digit under the first digit here. And then we start as normal. Start by multiplication 7 to the first digit. 7 times 4 is 28. So I write it here and I write 2 in a small font above this next digit like this. And then 7 times 2 is 14. 14 plus this small number left from the previous multiplication. So 14 plus 2 is 16. Again, what should I write? Only the first digit, 6 here. And I will put it in a small font next to the next letter, which is 1. So, and I carry on my multiplication. 7 times 1 is 7, plus 1 would be 8. So the final answer, 8, 6, 8. Then we move to the fourth question, which in different topics about rounding to significant figure here. So it asks you to write 236 correct to one significant figure. And what's mean by one significant figure? I need only one whole number here, one significant figure here. We have three significant figure here, isn't it? One, this is a significant figure. The second significant figure is 3. And 6 is the third significant figure. So in order to make one significant figure, I should keep the first digit in your left-hand side, the largest position, largest place here, and turn everyone to zeros here. But we have to look to the second place here. Second place here is 3. The rule here telling you if the second place is 5 or bigger, greater than 5, the first digit will turn into a larger number, will go one step ahead. But here it's less than 5. That means the first digit will be as the same. So look here. So this is the second digit. We will check if it's greater than 5 or equal 5 or less than 5. Since it's less than 5, we will keep 2 as it is and turn any figures afterward as zeros. So it would be 200. So now we have the answer with one significant figure. So this called the significant figure here. So the answer is 200. Come to the other question here. It's asking you, write 74.86 correct to one significant figure. So again, it will be the same. So how many figures we have? It will have 4 significant figure, 1, 2, 3, 4. But it asks for one significant figure. That means I have to look to this one and check the second one. Check this one. Is it equal 5, greater than 5, or less than 5? It's less than 5. That means we are going to keep the first digit as it is and turn any figures to zeros. So look here, this significant. The first figure is 7, and the second one is 4, which less than 5. That means it will be 70.00. Can you see here? So first one kept as it is because the second digit is less than 5 and turn all figures afterward as 0. So the answer is 70. This is the final answer. Go to the next question here. Telling you to write this number correct to one significant figure, only one significant figure. How many digits we have? We have 5 digits, so we have 5 significant figures here. But it asks us for only one significant figure. So look to the first one here. It is 2. And the second one is 4. And 4, again, it's less than 5, isn't it? And since it's less than 5, we'll keep the first digit as it is and then turn any numbers afterward to zeros. So it will be 20000. So this is the final answer, 20,000. We have only one significant figure here. This is called the significant figures. So this is your answer. Next question here is write this number correct to one significant figure. So here is a little bit tricky. What is the first significant figure? Zeros doesn't count as a significant figure if it's start or at the end. If it's the beginning, start with zeros, it's not considering a significant figure. If it's in the end, doesn't consider a significant figure. 0 could consider a significant figure only if it's come in the middle of the number. So here, if you look to how many significant figure, this is the first significant figure, this is the second significant figure, this is the third significant figure. So we will skip the significant first digit now and look to the second one. Is it equal 5 or greater 5 or less than 5? It's greater than 5. Oh, in this case, what we should do if it's greater than 5, we will turn 6 to the bigger number ahead. So the bigger number ahead is 7. So 6 will turn into 7, and then any figures afterward will turn into zeros. So that means it will be, the answer would be 0.07 and then 00, or we can ignore zeros afterward. Is it clear? And then come to this question here. We have this number in the question and telling you that Holly has worked out the answer to a calculation. Her teacher has told her to write all her answer to 4 significant figures. Round her answer to 4 significant figures. So in this case, how many significant figures that Holly has? 1, 2, 3, 4, 5, 6, and 7. But it asks to 4 significant figures. So since we have to keep 4 significant figures, so we have to keep this as it is. But we have to look to the next figure, which is 7 here, isn't it? And to check if it's less than 5, equal 5, or greater than 5. So this is a 7 which is greater than 5, and if it's equal 5 or greater than 5, so the significant figure in front, this one, will turn to the bigger number ahead. So 4 in this case will turn into 5. So again, 7 greater than 5 here, that's mean this 4 will turn into 5. So the answer should written be as 8 to 7.5. So this is 4 significant figure. Let's check. This first digit is 1 significant figure, second significant figure, third significant figure, and then this is the 4th significant figure. So this is the final answer. Here is round 74 to the nearest 10. Nearest 10s means 70, 50, 60, 50, 40, and so on here. So let's check. 7 in 10th place, 4 in the 1st place here. So we have to leave 7 and check by the second letter, the next digit here, which is 4. And again, let's check if it's 4 less than 5, or equal 5 or greater than 5, it's less than 5. That's mean I will turn 4 into 0 and keep 7 as it is. So the answer would be 70, as you can see here. Then here, round 852 to the nearest 100. So here is telling to nearest 100. That's mean we have nearest 100 means hundreds places like 700, 600, 500, 400, and so on. And when we look to this one here, this 8 in the hundreds place, then we need to look to the next letter, not to. We need to look to the next digit here, which is 5. And 5 is equal or greater than 5, isn't it? And if it's equal or greater than 5, the first digit will go one step greater. That means 8 will turn into 9, and other figures, other digits will turn into 0. That means it will be 900. So the correct answer is 900. Then to jump to the next question here, it's BIDMAS or BODMAS. Both represent the same things, it's just different. I and O here stand for others. I here stand for indices, but it's the same approach. Here the question asks you to insert brackets to make this calculation correct. Look to this one here. It's asking you to make this calculation correct. And the answer is 21. And 21, in order to get the answer, we need to apply BODMAS here. But what is 21 is? 21 is 7 times 3, isn't it? So we can adjust the calculation here according to BIDMAS or BIDMAS to become 7 times 3, yes. If you can see here, there is 8 minus 1. So if I insert brackets here, according to BIDMAS, B stands for bracket. That means brackets must be done or carried out first. So 8 take away 1 is 7, and then times 3. So 7 times 3 is 21. So the question here is asking to insert a bracket. So insert the brackets here to make the calculation correct. So this should be your answer. And question 12 here, telling you that Joe thinks the answer of this calculation is 40, while Albert thinks the answer of this equation is 24. Who is correct? Let's check. According to BODMAS, we have to write this one here, 4 times 2, and check. Which one should done first? According to BODMAS, multiplication should done first because B was stand for brackets, I stand for indices, D stand for division, M multiplication, so M appeared before addition. So that means I have to start with multiplication first. So it would be 8 and then plus 16 would be 24. So when this is not the answer yet, we explain the answer, but it telling you who is correct, so that means Albert is correct, isn't it? And why? As the multiplication needs to be carried out first before addition, and don't stop here according to BODMAS or BIDMAS. In this case, if you write this, you explained everything and you have the evidence that you used BIDMAS rule or BIDMAS rule, so you should receive the full mark here. Sometimes, if you said Albert is correct and you didn't mention it's according to BIDMAS, you will lose 1 mark. So calculate here. Calculate what? This one. And again, it's examine your knowledge about BIDMAS. Now you understand that multiplication come first according to BIDMAS. That means we're going to use multiplication first according to BIDMAS. So it will be 3 times 2 is 6, and then addition. So 10 plus 6 equal 16. Come for the first one. It's division here. There are 2 divisions and addition. So we have to start division first. 8 divided by 2 is 4. And then there is other division again. So 12 divided by 4 is 3. And then we perform addition. 4 added to 3 equal 7. So this is your answer. And carry on for the following question, which is about highest common factor and the lowest common multiples. So for question 14, find the highest common factor of 48 and 56. The best way to do this one is to use the prime factor tree, and you're going to use this method in your GCC as well. So we're going to start by writing 48 here and find any 2 numbers if multiplied together would be 48. You have to use your multiplication knowledge to answer this. So any 2 numbers. So here I used 4 times 12 is equal 14. None of these are prime factors. You should know what's prime factors: 2, 3, 5, 7, 11, and so on. So again, we need to reach to prime factors. So we need to find 2 numbers that if multiplied together become 4, which is easy one. It's 2 and 2. And if I found prime factor here, I make a circle so I don't confuse myself. If it's prime factor here, I make a circle. And let's look at 12. The easiest number here is 3 times 4. So, and again, 4 would be 2 times 2. In this case, 3 is prime factor, 2 is a prime factor, 2 is a prime factor. So I can't break down these numbers anymore since I reached the prime factor. So this is 48. Now I got to 56, second number. I will do the same way, prime factor 3. So 56. I don't know what are 2 numbers by 56. So don't be worried. Just in this aside here, find 56 divided by any number you think is easy. And the easiest number we should start with is 2. So 56 divided by 2, 5 divided by 2 is 2, and it's equal 4, remainder 1. So I write 1 here, and 1 and 16, it will be 16. 16 divided by 2 is 8. So 28 times 2 is 56. So here I write 2 and 28. And I know 2 is a prime factor, so cannot be break down anymore. And I made my circle here. Then I will try to find any two numbers if multiplied together become 28. So it would be 2 times 14. And again, 2 is a prime factor, cannot be break down here. So I mark it with a circle. And 14, I have easy two numbers, 2 times 7, and both of them are prime factors. And then I mark them with a circle. So now we have established prime tree for each two numbers. So what next in order to get the highest common factor? We need to search for a common numbers of prime factors for both trees here. So let's look to 48. I have 2 here and I have 2 there. So these are common here. So if this common here, I write what number is common is 2 here. So this is the first digit which is common. Try to find another common numbers. We can find 2 here and 2 there. So again, they are common here. So I write another digit which is common. Is there any other digit common between this tree and this tree? Yes, there is 2 here. And there is 2 there, as you can see. So I write 2. But there is no any more common digits between these both three. So now I multiply what I found common. 2 times 2 times 2 is equal 8. So the highest common factor of 48 and 56 is 8. So hope this is clear. Come to the second question here. Find the lowest common multiple of 60 and 75. How to do this one? Prime factor 3 again. So 60 break down to two numbers here. Very easy numbers here is 6. 2 times 10. I told you to do any two numbers. It finally, eventually, it will come to the same result. So 6 and 10, neither of them are prime factors. So both of them need to be broken down again. So 6 will be 2 times 3. So 2 and 3 are prime factors. That's why I marked them with a circle. So not confused by myself at the end. And 10, also easy. Two numbers, 2 and 5, and both of them are prime factors. So I need to stop here since I can't break down anymore. And look to the other digit, 75 here. So 75, how to break this one? I don't know what are two numbers, no problem. You say, go to a side of your page here and say 75 divided by a number you think it could be divisible. So 75 by 5, if any digit end with 5 or 0, it could be divided by 5. So that's why I select 5 here. So I select 75 divided by 5. 7 divided by 5 is 1, and the remainder is 2. So now became 25 divided by 5 is 5. So I have two numbers. If multiplied together become 75, it would be 15 times 5 here. So come to your prime tree, it would be 15 and 5 here. So 5 is a prime factor, but 15 is not. So I need to break down this one. And there is easy two numbers here. It's 3 and 5. Both of them, if multiplied, become 15, and both of them are prime factors. So now I can get my answer for LCM, lowest common multiple here. How to do this one? Again, you've tried to find common numbers here. From 60 there's 5, and from 75 is 5. So we need to cancel one of them. So I cancel 5 here. And is there any common numbers between both trees? Yes, there is 3 here and 3 there. So cancel one of 3's. So I cancel this one because it's common. I cancel this one because it's common. And the rest, which haven't been cancelled, must be multiplied together. So that means 2 times 5 times 2 times 3 times 5 should give you LCM, as you can see here. 2 times 5 times 2 times 3 times 5 equals 300. So 300 is the lowest common multiple of 60 and 75, and this is your answer. Look to this question here. What is the lowest common multiple of 36 and 45? Again, okay, you already know this makes a prime tree for 36. It would be easy, 6 times 6, and then 6 broken down to 2 and 3, 6 broken down to 2 and 3 here. So these are the prime numbers. And then look to the 45, easy numbers here, 5 times 9, 5 is the prime factor. and 9 broken down to 3 and 3 and 3 and 3 are prime factors. Now you can get LCM here. And how to do this one? We find the common between both trees. You can see 3 here and 3 there. We need to cancel one of them. I canceled this one, and anyone doesn't matter. And is there anything common here? There is another 3 here and 3 there. Cancel one of them. So cancel this one. So I canceled this one. So the rest of numbers, they multiply together will give you LCM. In this case, I will multiply 2 by 3 by 2 by 3 by 5 should give you the final answer, which is 180. I hope this is clear. And the next question telling you what is the highest common factor of 36 and 45 here. So we are going to use exactly same trees because these are same numbers here. So these are the same trees that we have done earlier here. And you should know now how to do highest common factor. You find the common for each one. So what's the common? Here's 3 and 3. So I write 3. This is the first one common. Is there anything common? Yes, there is 3 here and 3 there. So this, the other one common here. So nothing common anymore. So 3 times 3 is equal 9. So, and this is your answer, the highest common factor. Look to the next question here, question 18. A red light flashes every 6 seconds. A yellow light flashes every 4 seconds. They both flash at the same time. After how many seconds will they next both flash at the same time? This is funny one. I mean, you can imagine if there is a car have a signal and there is a next car to the first one has signal as well. But the first car give a signals every 6 seconds and the other car gives signals every 4 seconds. And you are watching this car and think when they are going to flashing at the same time. This exactly is the question asking for. We're looking for exactly at what time both of them will flash at same time. Such questions, it's asking for lowest common multiple thing. That's it, no more. And this is easy one. 6 prime factor here, it's 2 and 3. And 4, it's easy to be broken down, it's 2 and 2 here. Now all of them are prime factors. So you know how to get LCM now. Look to the common numbers, cancel one of them, and multiply the rest of numbers. So now we're going to multiply 2 times 3 times 2. 6 times 2 is 12. So after 12 seconds, they will flash at the same time. And this is the answer. And jump to the next question, which asks the prime factors. Now, I believe since we have done highest common factor and lowest common multiples at the beginning, so this is easy for you. But we will add something for each question, even if they don't ask. I'm telling you, to get prime factors, we are going to do this one. But yesterday we will do the format in index form. We will see now. So 36 in to put as the product of its prime factors, we're going to use the prime factor tree, find two numbers as we done earlier. So it will be 6 times 6. This is the easy thing here. And then break down 6, it will be 2 times 3. So now I know 2 is a prime factor, 3 as well would be prime factor. So nothing to do afterward at here. Jump to the second one and be similar to the other 6. So we have these prime factors here. So here 2 times 3 times 2 times 3 would equal 2 square times 3 square. You know how we got this one or not? Okay, so if we stop here, this is the answer of your question. 2 times 3 times 2 times 3, that means it's the product of its prime factor because these are whole prime factors we got. So this is your answer. But this is the same case that I mentioned here. Sometimes the question asking to get the product of prime factor, which is this one, but might be asked and put it into index form, which is this one. What's mean index form? 2 here. How many times repeated? 2 times. That means I can write 2 and the power of 2. What means the power of 2? That means it's repeated itself 2 times. Remember this. We're going to use this one a lot afterward. And then times 3, which how many times repeated? 2 times repeated. That means times 3, which repeated 2 times, which called 3 to the power 2. So this is the answer of if the question asks in index form, and this question doesn't ask in index form, but you have to aware of. So this is your answer, 2 times 3 times 2 times 3. This is the answer of this question. Let's look to the next one here. Express 100 as a product of its prime factor here. So we're going to write 100 and do the prime tree. 10 times 10, easy number here. It would be 2 times 5 for resistance, and similarly to the other one, 2 times 5. So the product of prime factor here would be 2 times 5 times 2 times 5. If you'd like to place this one into index form, so this is the answer for this question. But if you'd like to put this one into index form, how you are going to do it? You're going to write 2 power to the power 2 and times 5 to the power 5 to be looks like this. Sorry, 2 times 5 to power 2. So here 5 repeated 2 times, so 5 times power 2 times 2 power 2. This if you'd like to put in index form. And then let's look to the next question here, which I believe is the last question in your exam. So write 24 as the product of its prime factor. Here it's asking for index form. So let's see here. The 24 will be broken down to 6 and 4. Both of them aren't prime factors. This means we're going to break down them again. 2 and 3, if multiplied together, become 6, and both of them are prime factors. This 4 here is 2 times 2. Both of them are prime factors. So if we multiply these numbers, these prime factors, this would called product of prime factor. It will be 2 times 2 times 2 times 3. Here, how to put this is the index form, because the question asked what this index form. So 2 has repeated 3 times. That means it will be 2 power 3 times 3 here. So this is how many 2's here? 3 2's. That means it will be 2 to the power 3 times 3. If not repeated, there is no power here. That means the power is 1, but we don't write power of 1 here because it's repeated only once. So the final answer is 2 power 3 times 3. This is your answer. Hope this is clear for everyone, and thank you.